Hello, everyone. I hope you can hear me okay. So welcome everyone.
Good.
Perfect. Yeah. So welcome everyone to our first ever virtual ambassador day, our virtual specials for our CNCF ambassadors. And today we'll have a few presenters from the CNCF ambassadors community who will share their experience with working with different scenes, with different tools from the cloud native community and from the cloud native world. And the first presenter today is Gianluca, who will share his experience of working with Kubernetes. And his presentation is titled as Extending Kubernetes with Gianluca Robertson. Welcome, Gianluca.
Hello? Okay.
Yeah, we had some issues with enabling presenter mode for you, so sorry about the 30 seconds delay. We can hear you great, and we can see you, and now I will disable my face and Amy's face from the screen.
Let me see if I can get the right camera somehow. Yes, can. And webcams. That should be good. Now, let me share my screen. I'm sharing my screen, and that's it. I think you see my slides, or I don't know. I can see the chat, so who knows? I'm gonna go, and if something doesn't look good, let me know. I'm here to share my experience with Kubernetes, but in a different form. So I'm not gonna show you like Cube Ctl commands, or I'm not gonna show you how to use and deploy a new deployments or a stateful set or stuff like that. I'm gonna tell you what I learned during my experience writing code that interacts with Kubernetes, and why I think it is important, and what I did in order to make my Kubernetes extension somehow. So if you are new to Kubernetes, you saw this example, I'm sure, because it's in the Kubernetes documentation. And this is a very powerful way to interact with Kubernetes. So what you can do is to write a YAML file, and you can apply what you've wrote, and Kubernetes will try its best to meet your expectation. So this is, you are writing the state that you want your application, your pod, your service to be. And this is very powerful, but this is not the unique job that Kubernetes is good at. So in my opinion, Kubernetes is a declarative framework. So it's something that, giving an expectation, tries to bring you from where you are to where you want to go. And it keeps looping and trying to keep the expectation as the one that you told Kubernetes to bring you to. So in some way, you declare your state, and Kubernetes brings you there. Even if it is like, I want a pod, or I want a deployment that has 5 replicas of this pod, you declare that, and Kubernetes tries to do that. So that's why I say it's a declarative framework. And it's a framework because it doesn't work only for pod, for service, and for the resources that we all know. It works for more than that. And I'm going to show you how I learned about that. So Joe Beda, one of the founder of Kubernetes, tweet about Kubernetes as a platform for building platform. And this is the topic I want to highlight in my presentation. So I put together a couple of slides that doesn't really tell you, don't look too much about the the workflow. I just wrote like Kubernetes architecture on Google, and I pasted a couple of images that I liked. So it's not really important, the content, but as you can see, there are a lot of arrows and a lot of components like here. And if we, like, there is the kube proxy, the kubelet, the CNI, the CCM, the scheduler, there is etcd, and all those stuff has to work together some way. And it's the same if we look at the CRI container architecture. So the CRI is the container runtime interface, because as you may know, like, Kubernetes is not the responsible for the creation of the container. Like, it doesn't really know how to create a container. It is something that it demands to somebody else. And the container runtime interface, like Docker or Containerd, are the tools responsible for bringing a container up and running. And I think this is important to remember, because we see Kubernetes as a altogether like piece of code, but it is full of components and arrows and third-party services that work together. And in some way, all those pieces can be replaced with something that you need. And this is why Kubernetes it's so, everybody uses Kubernetes, and every cloud provider is able to deliver a very reliable Kubernetes experience, because they can swap the pieces with something that they control. So if you are on AWS or on Google Cloud or on OVH, you use the Kubernetes as a service environment that they serve, you are probably using a CNI that is the one that really match the needs from your cloud provider. So for example, AWS has a CNI, a networking interface that is able to use the VPC network. So you can use the VPC one and not a virtual one on overlay. So this is a way that you can see Kubernetes in its extensible form. But it's not the one that I really care. I mean, I care more on the user side for this presentation. So we are not cloud providers. I mean, I work for a cloud provider, but I'm trying to be a user here. So how can I and why should I extend Kubernetes for my purpose? So in some way, we need to justify Kubernetes. And I think this is like crucial. Kubernetes is complex, and everybody says that it's complex, at least. And I think it's complex, but it's also a complexity that we have to learn and trust, because Kubernetes brings our application healthy and our system running as supposed. So it has to be in some way complicated, let's say. And we have to figure out a good way to justify it. And I think for myself, the API is a very good way to justify like how Kubernetes works. So not really the kubectl, not really like whatever, just the way how much it is extensible and how many powerful things you can do, thinking about Kubernetes as a framework, as a declarative framework. So I think it's important to know, like in general for DevOps, that you have to play your own game. And even if like a tool doesn't really do natively what you hope it to do, because maybe it has just a very friendly and common implementation. Usually nowadays, all the services we use has an API, and those services and those APIs can be glued together and used for your purpose. So stop thinking about, if Kubernetes doesn't do it natively, maybe it means that I shouldn't do it. Sometimes it's true, because it's easy to have crazy idea, but sometimes it's reasonable and we should get there. So you know yourself, you know your team, you know your product, and you should build around your requirements. This is mainly, where I'm going with when I think about extending Kubernetes. A little bit about myself. Like, I'm a software engineer. I work at Nginx, and I'm an open source maintainer for a bunch of projects. And I'm a Docker captain and CNCF ambassador, and that's why I'm here. And when I'm not coding, I like to grow vegetables and stay outside. So if you follow me on Twitter, you will see me coding or hacking with hardware or growing vegetables. So if you like one of those, see you there. And Kubernetes follows the same rules that I just told you about. Like you have a kubectl, but if it's not enough, you can extend the workflow and you can do whatever you want. Sometimes you can just extend, like an extension can be a bash script that runs the kubectl and JQ and does like weird stuff. But usually you end up in a very unmaintainable and not that solid and reliable situation. So I think we can do way better than that. But just remember, it's okay to build something that works for you and for your team if you don't find it, or if you know that you can do better. There are a lot of different ways to extend Kubernetes. And as I told you, I mean, a bash script that wraps kubectl with JQ and whatever, it's already in some way a Kubernetes extension because it used Kubernetes to do something more or better or more tied to your use case. But yeah, it's not enough. You can do a Ctl plugin, for example. You can do, you can write your own binary on your own application, or maybe you already have your own application because we had live before Kubernetes. So we have like UIs and SDK and binaries that we used, and we want to make them more powerful, or we want to make them better in terms of reliability. So we can use the client Go or any other SDK that interacts with the Kubernetes API and make our application better. You can use custom resource definition, and you can use aggregation layers. The last one, I never use them, so that's why there is a link in there. And I'm gonna share slides later on, so you can click on links and see by yourself. But I mean, this is just a list, and there are more ways. But yeah, those are the ones that I use or I know about or that I trust. So let's start with the Cube Ctl plugin, because it's definitely the easiest way to an extension for Kubernetes that looks like that has the same flavor. And it's very simple because you just have to deliver a binary in your on your teammate machine that starts with the kubectl dash name. So if you have a binary, you name it kubectl dash your plugin name, and you move it in your path, you can run it as a kubectl space plugin name. So this is an example. If you have a binary called kubectl-ns, it means that you can run kubectl-ns, and the kubectl will look for the kubectl-ns binary and will run it. A binary called kubectl profef, it's an example I developed, runs as a kubectl profef command. That's very easy. And you can write your plugin as you want, in every language, in Bash, in Go, in Python, whatever. Obviously, you write a plugin that in the kubectl, if you need to interact with Kubernetes somewhere, you don't have to do it, but I tend to write Kubernetes plugin when I have to use the Kubernetes capabilities. Like, for example, if I don't want to use the client Go because my plugin is not that complicated, maybe I'm just doing manipulation, using a kubectl plugin is good because I know that people needs to have kubectl available in order to run my plugin. So a very basic example is like I want to simplify a list of the way I list pods, because maybe I have to do a bunch of kubectl filtering jumps. You can write a bash scripts that use JQ and kubectl. You wrap it as a kubectl plugin, and that's it. So I wrote an open source a project that I like. It's called Profefe and Kubernetes. So Profefe is an open source project that does continuous profiling of pprof application, like Go use pprof. So what you can do is you have your Go application and you use pprof, that is like a profiler that goes over HTTP. And in some way you want to collect profiles every minute or every hour, and you want to store them somewhere, and you want to have a good way to visualize and aggregate all those profiles. So Profefe does that. And I place like a very simple diagram. So you have the Profefe collector that stores profiles like in somewhere like on S3, and you have a cron job that once a while goes and talks to your application and takes profiles. Oh, that's it. So I wrote a bridge, as I said, between Kubernetes and Profefe, because there is a lot that we can automate in terms of how can we collect continuously profiles from application running in Kubernetes. So I wrote a binary called kprofefe that is like the cron job that you saw before. And I wrote a Cube Ctl plugin that like helps you to interact with Profefe and Kubernetes itself. Like the end goal for me was like, I want to know the IPs, I want to know all the pods that needs to be, scraped and all those stuff. I mean, I can do that manually. I can do kubectl get pod -o wide get the IP and list all the IPs and fetch with Profefe, but that's a lot of work. I want to do it better. So the kubectl Profefe plugins works as you can see. You do kubectl Profefe --help, and you can see the flavor. So there are a few commands like capture, get, help, and load. And there are flags, and those flags are --kubeconfig, --namespace, --selector. Those keeps the same flavor as the Kubernetes, the kubectl plugin. So this is very important if you want to write an effective kubectl plugin. And in Go, there is a library that is called Runtime CLI. It's in the Kubernetes organization on GitHub that helps you to write applications that use the same flags as the kubectl. If you work in Go, there are more advantages because Kubernetes is in Go, so you can reuse a lot of the code that they already wrote for you. So I wrote a bit about Kubernetes plugins on my blog, so you can have a look at that. There is not a lot of time; I just have half an hour, so you have to dig a little bit by yourself. And as I said, kubectl plugins is a way to go. Another one that is super flexible is the client Go and any other SDK. It really depends on the language that you are using. So there are at least two categories of SDKs, the one that are supported by the Kubernetes community and the one that are not supported by the Kubernetes community. But at the end, the Kubernetes API is just an HTTP server. So if your language has a HTTP client implementation, you can interact with Kubernetes. Obviously, it is way more comfortable and way easier if the community gives you a library. So luckily for you, if you use Go, JavaScript, Haskell, Python, Java, .NET, you have a client library supported by the community. If you don't use one of those languages, there are other SDKs coming from like other communities that are not officially maintained, so you really have to figure it out. And as I said, Golang is for sure the best language to interact with Kubernetes because there are a lot of utilities, and Kubernetes is written in Go, as I said. So kprofefe is another part of the binary that I wrote as a bridge between Kubernetes and Profefe, and the binary used the client Go library to do a bunch of stuff. Like at least it retrieves all the pods. And when you do Ctl Profefe get, you can filter by label selection or namespace. So you can use the -n or the -l in the same way you do when filtering for other resources like pod, services, and so on. And all those stuff comes from the client Go itself. So this is the first stage because I have in some way to get the targets for my scraping. And I also use annotation to mark the pod that needs to be scraped. So when you create a pod, you use annotation that are key value pairs to say, okay, this pod has a pprof entry point, and it runs on port 8080, and you should use the path /debug/pprof. So this is a piece, a very small part of the code, but as you can see, this is the get selected pods. So it uses the client set for the core v1, and it asks for all the pods in a particular namespace, and there is a list option that you can use. And usually the list option is filters by the labels that you specified, and you get a list of pods back. So you do a for over the pods, and I look for the pod annotation, profefe enable annotation that tells me, okay, this pod is a good candidate. And I also check if the pod is running, because if it's not running, I don't need to scrape it for a profile. Another piece of code that I wrote that is very useful, and I also took it out from profefe and I made it its own little library that I call Cube Port Forward. Is the code that the kubectl uses when you do kubectl port forward, and I use that in profefe in the profefe kubectl plugin, because you can do kubectl profefe capture, and you place the name of the pod. So with that command line, what I do is I get the pod, I get the port, and I forward, and I do the forward automatically. So in this way, my plugin can always reach the pod running, even if the network is not, my local network is not connected directly to the Kubernetes one. And I think it's super useful. And this is another example of something that is not that common, that you can still do by yourself. Another way to extend Kubernetes is writing your own custom resource definition. I placed it there because they are very popular, and a lot of people and tools that we use custom resource definition. I personally think that you should really think deeply before implementing your CRD, because it's not that easy, or if you want to write a good one, there is a lot of low-hanging fruit. But in some way, if you use Terraform, you know the concept of modules, so you can bridge Terraform with the API that you want to use. There is even a Terraform module to order a pizza on Domino's, I presume. And you can do the same as a CRD. So the CRD is a way you have to bring the declarative framework that Kubernetes serves to resources that are not the default one. So there are native resources like pod, services, deployment, stateful set, ingress, and all those stuff. You can write your own one. So if you run on, I don't know, AWS, and you want to manage S3 buckets as you do for pods, you can write a CRD for S3 buckets. So you can do kubectl create S3 buckets. And you don't have to do it, because the AWS team developed a project called ACK that does that. So it has a bridge between S3 resources and Kubernetes resources. So you can manage them in the same way you manage Kubernetes resources. If you used Cert Manager, you probably saw something like this. So the kind certificate, if you look at that, it looks like a YAML that you use for Kubernetes resources. But the certificate has an API version that is the certmanager.io/v1. So it's not something that Kubernetes supports by itself. It's something that has a custom resource definition from the Cert Manager project. So as they did that, you can do that as well. So I'm not going to tell you to write your, I don't know, event manager, like the one we are using today for this presentation, for using Kubernetes, but definitely it's something that you can explore, but don't do it. The way CRD works, they work in this way. So you have the API server that is a Kubernetes component, and you deploy your CRD controller in Kubernetes, and you register the CRD to the Kubernetes API server. So every time client go and the kubectl will interact with the API server as they do for any like resources like pod services, if they call your CRD, the API server will know who to ask for. And like it works almost in this way. Technically, it fires events and does stuff like that. But like the general idea, if you never look at the CRD, that's how you should think about it. So why you should write your CRD, or why you should extend Kubernetes, like because your team uses Kubernetes a lot, or you are training your team to use Kubernetes, and you know more your teammates use a tool, better they will become at using it. So it's good to onboard a lot of workflows to the same tool. So you can make available if you use like Cloudflare DNS, you can in some way write the CRD that bridge like Cloudflare and Kubernetes. So they don't have to go to Kubernetes to Cloudflare every time if they have to change DNS, but they can do it with the Cube Ctl. Another reason to write like extension for Kubernetes is because Kubernetes itself gives you a lot of stuff for free that usually we don't really think about Kubernetes as a way to do authentication and authorization, but it does that. I mean, Kubernetes supports Airback, and there is a concept of like TLS certificates, and all this stuff can be reused if you write a CRD, for example, or if you write a Cube Ctl plugin that uses the client Go. The client Go has a way to authenticate with Kubernetes, so you always know who is interacting with Kubernetes, even if it's a random binary. That it's always better than having like unauthorized application, unauthorized interaction. Like audit logs, it's also a feature that comes with Kubernetes, and it's also something that you get when you do a CRD. So if people interact with your CRD, audit log, authorization, authentication comes for free. Even the event system, Kubernetes is an event-based like application. So everything that happens triggers an event that you can listen to, and this is another powerful way to extend Kubernetes. For example, I had to pass through labels from an EC2 as a Kubernetes node label. So from an EC2 tag to a Kubernetes label, and I wrote a very small binary that is watching for when a new node joins a Kubernetes cluster. And when a new node joins, I use the annotation from the node to get the instance ID, and I look for the tags, and I pass the tags from the EC2 to the Kubernetes node. So this is another like extension I wrote. So as I say, there is not much time. I have like 2 minutes left, and all of this comes from a free ebook I wrote with O'Reilly about. It's called Extending Kubernetes. So if you want to know more, you want to see more code and more examples, the book is for free, so you can have it. So I don't know if we have time for questions or a way to get questions. Otherwise, as I said, DMs are open on Twitter, or just send me your question and I will do my best to answer. So thank you.
I think we have time for one question. Pretty short, like we have 2 minutes. So if there are any questions in the chat, let me check them briefly. I don't see any questions in the chat yet.
That's good.
If not, so Gianluca is online on Twitter and other places, so feel free to reach out to him directly as he suggested. Thank you, Gianluca. It was a great presentation. And
thank you for having me.
Yep, thank you, Gianluca. And the next one, is Jerome. Jerome, are you here? Here we go. Maybe stuck a bit with enabling the presenter mode. There are some temporary issues with enabling Jerome as a presenter. So let me check this briefly. Apologies for some delay.
Jerome, I have made you a host. See what you can do to be able to go and turn presenter mode on. Crickets? Oh, let me try and reload the whole page. Hooray! Yay, fun.
So let's wait 1 more minute before hopefully we'll fix these issues.
Super. We might have Jerome back.
So please welcome Jerome, and he will share his experience. His presentation called "Switching Engines Mid-Flight to Replace in Our Cluster Spot."
Let's see. Okay, of course, if I try to share my screen, it's going to share both screens, which is absolutely not what I want to do. I just want to share the screen where I have my slides and terminal. Well, let's see. Perhaps I can try that. Okay, so now, okay, I suppose now you can see these slides. However, I guess if I do that, you can't see the terminal, can you? And I can display the chat as well on the sides. Slides. So I don't get like what we call the confidence monitor. So I don't know if I'm sharing the right thing with you right now. The thing is that I have a screen where I intend to be switching between my slides and my terminal, and I just don't know if this is what's happening right now. Sharing the presentation. Okay, and you can see the terminal.
But we don't have terminal, so let's roll it and see what we can do.
Okay, let's see how I can address that. Interesting. Select window or screen. Because basically my other option is to do that, where I suppose now you have a giant vertical screen where you have my slides on the bottom, and then how do we call that? Une mise en abîme, where we have the video in the video in the video in the video. Well, just give me 1 sec to conjure up a solution to that interesting problem. Let's see. I'm just gonna take 1 second. Maybe I can just disable that one of the 2 screens and just merge everything on 1 screen. How am I going to do that? Let's see. Yep, that's i3. I'm using i3 indeed. And maybe I can just disable one of these screens or just mirror both screens, and then I will get everything there. Yeah, the first option was good, except with the first option, you won't see my terminal. You will only see the slides, and half of what I'm going to show is going to be in the terminal. So it would be, well, maybe I could just lay them one on top of each other, actually. Well, maybe we could do that and see what happens. Let's see. I'm going to share again and share the entire giant screen. Yep, let's do that. Then I'm going to move the Bevy window somewhere else. And then I'm going to, yes, like this. Well, except now, if you use the chat or anything, I will have no idea. So I'm just going to, oh, so much windows. So much windows. This can all go somewhere else. All right, I guess we're gonna say that this is good enough. Switching to where is my terminal now? There we go. All right, so I'm going to talk about switching engines mid-flight, how to replace a Kubernetes cluster pod network while it's running. I look for illustrations of people trying to switch the engine of a plane while the plane is flying, but for some reason there is no illustration of that around, and I suck at drawing, so I could not make one myself. So I'm Jerome Pitazzuni. You probably heard about me because I used to work at Docker. I worked there for an incredibly long time. And I love music, tinkering, infrastructure, and teaching. So in the field of music and tinkering, usually I play with things like this and a Raspberry Pi, and then we can do some music with it. But that's not what I want to talk about today. Today, I'm going to talk more about the infrastructure and teaching aspect of it. By the way, the slides that I'm showing here are available on container.training/please. So if you want to check the slides, and I will also put the URL back up at the end of the presentation. Okay, so first, why are we doing this? Why would I want to change the pod network on my cluster? Well, as we say, it's not about the destination, it's about the journey. There are very few real-world use cases where we would want to do that, but at some point I had this idea. Actually, somebody asked me, hey, how can I change the network on my EKS cluster? And it got me thinking, okay, how do we do that? And by trying to do it, I stumbled into a bunch of really interesting things. And so I thought it would be interesting to share this adventure, basically. So I'm going to give some definitions. What the hell is the pod network and why should I care? I'm going to give you like a very specific use case so that you can see where this is actually useful. And there's going to be a bunch of demos and actions and various shenanigans. First, what is the pod network? Well, a quick reminder on Kubernetes networking. I like to think of the Kubernetes network as a 3-layer lasagna, where we have the pod-to-pod network. So that's the part that ensures communication between pods. Then we have the pod-to-service network. So that's the thing that comes into play when you use like cluster IPs and node ports. And then you have network policies like the firewall of Kubernetes. The beauty of Kubernetes, in a way, is that these 3 parts are completely independent from each other. So you can switch them. You can switch one of them without touching the others. And to me, like, it shows that the architects of that model really knew what they were doing, because you could switch the firewall without changing the load balancing part or vice versa, etc., etc. Now, when you put everything together, that gives us this really interesting diagram, which is very confusing, but trust me, it's just unicorns and rainbows behind the scenes. So if you want to know more about Kubernetes networking, Tim Hawkin will be like your man. He made a bunch of really excellent presentations explaining like what it's all about and also giving a lot of implementation details. So I sprinkled a bunch of links here of presentations that he made. But Now, why would I want to change my pod network? And I'm going to give you a very real example. So on top here, we have a Kubernetes cluster that I just deployed on EKS, like just before this presentation. So I gave it, oh, interesting, I just lost access to my machine. Let me reconnect. There we go. Okay, so I was saying, I just have a Kubernetes cluster that I deployed just before that presentation. I just scaled it up to 4 nodes. And if I do kubectl get nodes, I should see all 4 of them. Wonderful. And so I'm going to deploy 123 pods. First, I'm going to just deploy a little application just for fun. I'm going to deploy a console cluster. Let's see. That one is going to be our canary, kind of, because I want to make sure that whatever horrible things we're going to do to the cluster, the canary will still be alive and the data will still be there. So once I do that, a few seconds, okay. A few long seconds later, we will get our console cluster. And once it's up and running, I'm going to just store a couple of key value information in there. There we go. It's just going to be 3 nodes. So let's give it some time. Yeah, this is not the fastest Kubernetes clusters north of the Mississippi, but it should do for the demo that I want to show you today. And I should have deployed that console cluster beforehand as well. I just didn't expect that to be so long. Then I'm going to leave it work a little bit. So what I want is to deploy like a bunch of containers. So my go-to application when I just want to create a bunch of containers is Nginx, because it's small, it's fast, it's lean, and I just do this usually. Like I create a deployment called web using image Nginx. That's my hello world in all things Kubernetes. Okay, cool. My cluster, my console cluster is up, so I can do something like this. Exec console 0, and then I can use console kv put hello world, so to store in the key hello the string world. So now when I do this, I get world. So this is my canary, all right. I hope that at the end I can get that string back and it will still be there. All right, now I'm going to scale that deployment to 123 replicas. And when we do that, what we see is that it won't quite work. I'm going to kind of spoil you the suspense a little bit, because if I wait for the whole thing to happen, we might end up running out of time. But basically, a bunch of pods are going to remain pending here. And if I check the events on my cluster to know what's up, we're going to see some message somewhere telling us here, for instance, oh, failed to assign IP address to container. And the scheduler should even tell us basically that the cluster is full. We should have a bunch of pods remaining pending, as if like our cluster had a kind of limited capacity. And indeed, it does have a limited capacity. If I have a look at my nodes, like one of them here, and I kind of sieve a little bit through that output, I'm going to see, let's see, where is it? Allocatable, yeah, here, capacity pods 29. This means you can only have up to 29 pods on that node. So we're like, why? Why am I limited to 29 pods, even though I have a bunch of memory and CPU and et cetera, et cetera? This is because by default on AWS, when you run a Kubernetes cluster, it's going to use the AWS VPC CNI plugin. So my pod network, the part responsible for connecting everything together, it's going to make the pods part of the VPC subnet on AWS. So each pod will have its own IP address that will exist in a VPC subnet. These IP addresses will be linked to an ENI, like a virtual network interface, basically. This is all nice and fancy, but there is only a limited number of interfaces that you can put per VM and only a limited number of addresses that we can put per interface. So the downside is that this limits me on the number of pods that I can deploy. We've just seen that. So I should also mention the upside, which is that when I do that, then my pods are going to be visible and to exist from the perspective of my EC2 VPC. So I will be able to have communication between my VMs and my pods, like direct communication between them. So that's great if you want to have mixed workloads with pods and VMs. Awesome. But it's less great if you want to have a bunch of pods. So what we're going to do is that we're going to get rid of that AWS VPC thing and put something else instead. So for that, I will need to get root access to the nodes because I will need to do some low-level surgery on them. How do we get root access? Well, on every cloud provider, it's going to be a little bit different. Of course, I'm sure there is a perfectly nice and proper way to do that on EKS, just like there is a really nice and proper way to do that on Capsule or OVH Cloud or DigitalOcean, etc., etc. Except I really don't have the time to learn the 8 or 10 different ways to get root. So instead, I'm going to let myself in, just like the way that hackers do, and I'm going to hack the planet. So I'm going to use this very convenient hack the planet YAML. What's in there? So that's a daemon set that's basically, long story short, it's going to add my SSH key to every node of the cluster in the root account. Yeah, it's not very subtle, but it works, and it works on any Kubernetes cluster. Well, almost any Kubernetes cluster. Now, let me just scale back down my deployment here. So we just need to wait maybe a little minute for my Hack the Planet thing to kick in, and then I will have root access on my cluster. Now, if I were to tell you a way to get that kind of root access without telling you how to mitigate it, I would feel like an asshole. So I'm going to give you a few ideas, like how can you prevent that kind of stuff? How can you prevent your developers from just applying a YAML and boom, getting root access on the cluster? One way is to prevent SSH connections. And actually, on EKS, by default, the nodes are in a security group that prevents SSH connections. So I had to open SSH connection in the security group for that to work. Another way is to enable pod security policies. So that will let you prevent some features from being used. For instance, no host path volumes, no privileged containers, no etc., etc. You could also use a policy engine, which is a kind of even more generic way of preventing some features and enforcing some conventions in your cluster. All right, so my Hack the Planet thing is running. And so normally now I can just get the IP address of one of my nodes, let's say this one, and then I'm going to SSH root here, and there we go. I'm in. So I'm in. I'm on this EC2 instance, which is part of my cluster. So I wonder, kind of, okay, why do I have this limit of 20-something pods on the node? And if I look here, I can see that in the arguments of kubelet, there is a max pods 29. So that's the first thing. So my first idea was, well, what if I just change that? I bump up that value and then I restart kubelet and we see what happens. Well, what happens then is that you break networking, because this is here to prevent us from allocating too much ENIs and IP addresses, and etc. But if I raise this, I don't get rid of the underlying limit. So this is not the only thing that we need to do. We also need to actually switch the pod network for something else. Okay, so the first step is to get rid of the current pod network. So I'm going to switch to the Cube system namespace to do that. And in the Cube system namespace, I see a bunch of things, including a daemon set called AWS node. So that's the thing I want to remove. Kubectl delete daemon set AWS node. And then I need to install another pod network. So I'm going to use one called Cube Router. So Cube Router is extremely popular with folks running Kubernetes on-prem because it's very simple. It doesn't provide its own plugins, etc. It's using protocols that are well known to network admins. It's building a BGP full mesh between your nodes. So if you don't know what BGP or full mesh is, you might be like, duh. But if you are a network admin, these words probably kind of tick a number of boxes in your mind. So how am I going to install that? Well, I'm going to use Helm and the Helm repo list. And so I'm going to use a Helm chart for Cube Router that has been made by my friends at Nginx. So Nginx/Cube Router. And I think that should be pretty much it. So it comes with sane defaults. So if you wonder, okay, what's the point of using this Helm chart instead of just some YAML? When you go to Cube Router, they give you a bunch of different YAML depending on the scenario that you want to use, etc., etc. So the Helm chart has pretty sane and efficient defaults, so that's great. Now, we still have a few things to fix. See, oh, crash loop back off, what's going on? So we could have a look at the logs of these pods. And here we see that we need a pod sider. So we need to allocate a subnet to each node on the cluster. This is the case for pretty much like half of the CNI plugins that we could use. They want something to allocate a pod sider. There are multiple ways to allocate a subnet to each cluster. We could add a flag to the controller manager so that the controller manager does it automatically. That would be the simplest option, but as far as I know, it's not possible on EKS. We could edit each node to set the pod sider, or we could annotate nodes. So this is what I'm going to try and do. So I have the command that I want to use just in a corner here. So let's see, I just have to do this little for loop. So for node in kubectl get nodes -o name do kubectl, okay, let's see. I need to do a little for loop. So let's start with I = 1. And then let's see, subnet equal 172.17.n.0/24. And then kubectl annotate kuberouter.io/podsider equal this subnet. And then increment n, and that should be it. Whoops, what did I do wrong? Right, I forgot to put $node here, my bad. Okay, so we annotated each node. So now I just need to give a little kick in my pods to get them to restart. Let's see. And normally when they restart, they should be way happier about current state of affairs. So if I check the logs here, okay, so that's better. KubeRouter is now up and running. And so at that point, if we had a little bit more time, I would show you what happens if we try to run a bunch of pods. It still wouldn't work. And so when it doesn't work at this point, we have to like, okay, why is it still not using my brand new CNI configuration? Well, if I go back to my Kubernetes node, basically, we have a CNI configuration in etc CNI net.d. So when kubelet needs to create a pod, it's going to invoke CNI plugins. So imagine like a little kind of assembly line, a pipeline of operations that we do so that we prepare the network of a pod. And so to decide what this pipeline will be like, what this assembly line will be like, we write a CNI configuration, and we put that CNI configuration in this directory right there, etc CNI net.d. And so what kubelet is going to do is that it's going to get the first configuration file that it finds in this directory. And so at this point, it's still taking the 10 AWS conflist file. So I need to remove that file from all of my nodes so that kubelet starts taking the other file. Okay, so I'm going to do a little loop on that. Let's see, kubectl get nodes. So I need to get all the IP addresses of my nodes. So I will, let's see, status.addresses. Okay, so the external IP is the first one in that loop, dot address. Ooh, I forgot the dot. Perfect. So for IP in all that, do SSH root at IP. And then we need to remove the old file, net.d 10aws.conflist. Then we also need to, okay, so oops, and I got that wrong, so that's not gonna work. Let me try again. It's at $IP. So I remove that configuration file. Normally, I should also change the maximum number of pods in kubelet, but I don't think I will have the time to do that part. So I'm just going to take care of that part and see if that does the trick. So I won't be able to start the 123 pods I was promising you earlier, but normally at this point, if I try to start pods on my cluster, so let's go back to the default namespace and let's scale back up this deployment. And normally what should happen now, you can see here, these are the old IP addresses that were assigned by the AWS CNI plugin. And normally, if everything goes, yes, perfect, these are the new IP addresses allocated by KubeRouter. So if I want to complete the work, I actually need to delete these pods and let them be recreated. Kubectl delete pods with app equal console. And then the new pods will be recreated instead. And thanks to the magic of persistent volumes and so on, they will pick up the data, like the little canary data, the hello world key value that I've put there in the beginning of the presentation. It might just get a minute to get there, so I don't know if I will have the time to show you that. But anyway, right, and so that works. So some little details, if you want to run that in your own environment, you might have to tell KubeRouter to force the overlay network, because if in some environments, it will believe that your nodes are on the same subnet and that it can use direct routing between them, and you don't want that. You will want that extra flag. And as I was saying, all the pods using the old configuration will have to be recreated. Now, if we want something with a much smoother experience, that blog post, and actually after I proposed that presentation, I felt really embarrassed because, as you can see, it's very hackish and kind of, okay, let's try and do that and just like hammer on this cluster until we get it right. And then these folks just published this blog post explaining how to do that, but the proper way. So what they do is, instead of just hacking away the pod network, we get both old and new pod networks running side by side with a kind of meta network, and then we do a really nice and smooth transition from one to the other without breaking everything, just like I did there. But I mean, I learned a lot while I was doing that, and I tried to show you like some of the things that were involved there. Okay, let's see. Okay, my console cluster has restarted, and if I try get hello, it says world, so my data is still here. Awesome. Thanks. I think I'm exactly out of time, so I don't know if we will have time for questions. If you want these slides, you can get them at container.training/please, and there is also a little question so that you can tell me what you liked or did not like about this presentation, so I can iterate and refine on it. All right. Thanks a lot.
Thank you, Jerome. Right, unfortunately, we don't have time for questions right here, but everyone, please share questions with Jerome later online. So our next speaker after Jerome is Jeffrey Sika. So Jeffrey, if you're here, we'll let you in. Jeffrey, now you should have the presenter permissions on, and you should be able to join us. Yep, Jeffrey's joining us. Let's wait 1 minute. All right, so Jeffrey's going to reload as well. And here's Jeffrey.
There we go. Okay.
Perfect. All right.
Definitely have to reload if you've been in here longer.
All right, good tip. How are you doing today?
I'm doing awesome, except it's feeling like autumn, so yeah.
I guess it is. All right, so please welcome Jeffrey. Jeffrey has another half an hour for sharing his insights about the cloud native world.
Yep. Am I coming through good? Do I sound good? Does that look good? If I Alt-Tab, does it do it right? Can you see my terminal? Perfect. All right. Let's have some fun. Welcome to the Cloud Native Circus. With that said, let's dive right into an ocean of entertainment. My name is Jeffrey Sika. I work at Red Hat, but I also happen to be a CNCF ambassador. That's why I'm here. But today I'm going to be more of a CNCF jester. Pretty much everywhere on social media you can find me at Gphy. I'm also in various capacities in the Kubernetes community, and one of the other things I happen to be well known for is being a Goose enthusiast. I'm sure many of you were curious what the heck this talk was going to be about. Also, at this point, I think it's expected that any talk I do will have some geese in it, so I may as well lean into it. So I want to go over what Untitled Goose Game is and how it kind of stuck in our community. I want to talk about what Ctl is and why it became so popular. I want to talk about this idea of like a cloud native computing fugue, versus cloud native camaraderie and fun. And by fugue, I mean this tech has a way of getting our eyes to glaze over at times, and it's not easy at face value. It's more like an onion. There's lots of layers, and the more you peel back, the more likely you'll cry. And I also want to talk about why we need to have more fun. For those of you that already know what Untitled Goose Game is, I'm sorry, talk to the goose. For those that don't, let me explain what Untitled Goose Game is. In Untitled Goose Game, you play as a goose. You are given a somewhat malicious to-do list in the format you saw in the last slide. And the goal is to complete the items on the to-do list. This type of game format is somewhat like what's called a sandbox style game, except in this case, the sandbox is small and you're a very naughty goose. So much of what the goose does involves terrorizing this town, but there is another angle to it. The goose constantly maneuvers and manipulates the environment to circumvent rules, boundaries, and other limitations, trying to keep the goose in check. It's no surprise that this goose was adopted into many tech circles, especially in security as an avatar of chaos. Now, with that out of the way, I want to talk about Convergent Evolution. It's the idea that, given similar environments, things will evolve in similar ways to overcome or optimize their lives. Jiffy, I hear you ask, why did you just jump from explaining a video game to starting a biology lesson? Well, did I say convergent evolution? I meant convergent memeolution. The idea here is because friends on the internet have similar six senses of humor and have exposure to very similar information streams, memes and fun ideas often come about at the same time from different people. As an aside, I wanted to joke and say memeolution or memeolution, but I figured they would cut the mic and move on to the next presenter, so I just wanted to move on. Hollywood has this problem all the time. It's also called twin movies, no relation to Twin Peaks. This involves similar movies that are released in close proximity to one another that started production almost at the same time. In true on-brand fashion for this talk, a great example are two of the best video game to Hollywood adaptations. The Witcher has nothing on Christopher Lambert as Raiden. So let's bring this all together and now talk about Kubecon North America 2019. As I've mentioned, I do various things around Kubernetes, one of which at the time was helping organize the Contributor Summit. My best friend, Bob Killen, whom many of you know, got to talking with me one morning about the Contributor Summit, and we decided we wanted to try and do a goose-themed scavenger hunt, and that idea spiraled wildly out of control into a contest to make a brown paper bag honk. We had our own Untitled Goose Game to-do list with various challenges, the simplest of which was just honk at Bob or Jeff. The bag had a Bluetooth speaker which would honk based on tweets or Slack messages, and people had to figure out and trigger the honk in front of us to be eligible for the patch or one of the prized geese. We thought, this is hilarious and good, clean fun, and everyone seemed to enjoy it. And throughout KubeCon, Bob and I were frequently honked at. Little did we know, the patron saint of Honkernettes, our very own Ian Coldwater, planned on delivering one of the best keynotes, or goose notes, honk note, ever. It doesn't matter. It was fantastic. It laid out how we should always consider the perspective of an attacker and how Untitled Goose Game is a great analog to thinking about security from the eyes of a malcontent. It is seriously excellent, and if you haven't seen it, please go watch it. You will be better for it. The progressive honking, the constant element of fun, jokes, aha moments that Untitled Goose Game brought us at KubeCon ultimately cemented it in our community's culture for the foreseeable future. We are all geese in the machine, and apparently my dog laying next to me wants to honk at everyone, so I apologize. It is in our nature to have fun. Yes, everyone's idea of fun is different, but our natural state is to seek out fun. And it is that drive and creativity that, no matter the circumstance, allows us to turn even the most complicated or boring at face value tasks into fulfilling and enjoyable moments. Cloud computing, cloud native computing, it's not easy for many. It's complex. There are progressively more and more layers. And if you talk to someone that's outside of the know, it can be intimidating. I want to showcase some of our community's more memorable instances of fun, and what better way to start off than breadsticks? During his leading of the 116, another one of our ambassador-owned, Lockie, became known as a breadstick aficionado and general Olive Garden enthusiast. It was an endless barrage of Olive Garden memes, gift cards, photos, trips to the restaurant, all culminating to the Kubernetes 116 logo. For those of you that didn't know, yes, Kubernetes 116 was indeed powered by and advocated for unlimited breadsticks for all. So prominent is this meme that to this day, Lockie is synonymous with breadsticks to some. Brandon, you weren't that far off, and not even 2 days ago, I could have copied another tweet. This meme is still going. Another creative way of having community-based fun I've seen recently is Cards Against Containers. It's a play on Cards Against Humanity. In the game, one player draws a card containing a phrase with one or more blank words. It's kind of like Mad Libs. The rest of the players must try to make the first player laugh as much as possible given their hand of phrases or words. For example, if I had the card blank makes my job exciting and someone played dumpster fires, I'd laugh heartily and likely pick that card. It's a simple format and it's endless amounts of fun. During the 2018 Seattle Kubecon, the community decided on Twitter it's not Kubecon, it's Kubecon! I hope that's not too loud, I apologize, but you have to put it in there. With Google's Borg being Kubernetes' distant uncle, and other various Star Trek references in Kubernetes, this was an incredibly on-brand joke. And of course, the meme was made manifest with stickers. And in fact, Valerie wound up making stickers and having them overnighted to the con. It was amazing. It's definitely stuck around in the community because a full year later, people, a la Gwyn, are still screaming it at dinner. Goose stickers weren't the only thing that happened at the 2019 Contributor Summit North America. The lead of that summit, Paris Pittman, bestowed upon her mighty crew captain's hats embroidered with the person's GitHub handle. It was a wonderful gesture and also helped throughout the summit as people looked for anyone wearing the hats for help. Mission accomplished, and also totally on brand with everything else in Kubernetes being nautical themed. And with many of us being engineers and open source developers, of course there will be some technical nerd fun in the form of slash commands. Throughout the Kubernetes repos, and even on Twitter now, you can /honk, /pony, /woof, /meow to your heart's content. There's nothing quite like seeing some progress on that complicated PR and deciding to celebrate on its impending approval with a big old picture of a cat. Luna. Finally, let's talk about something a little bit different. Let's talk about Doom. What? I'm a sucker for hard transitions in this talk, but hopefully I've gained your trust enough to bring this back around. Doom is an iconic video game, and it's one of the original first-person shooters. What does slaying demons on Mars have to do with Kubernetes? Well, someone with as sick a sense of humor as I have thought it'd be a fun idea to take Doom and make it into the most violent chaos engineering tool ever. Sure, it's impractical, but you can't argue that it doesn't sound fun. And though its practicality is limited, the fact that someone plumbed this all the way through was probably driven by their need for a fun project. And it's those types of projects that most certainly teach lessons along the way. Fun does drive innovation. So these were just a showcase of silly things, but our community would actually not be the same without them. In fact, I'd like to argue each of these in their own right benefited the communities and more than just having fun. This is one of my favorite pictures. It's a shot from the 2019 Contributor Summit, Kubernetes Contributor Summit, the same one with all the hats and the honks. This isn't just a community. This is a group of close-knit, welcoming, and loving friends. And so some may think that these are just inside jokes or you had to have been there. That's simply not true. In fact, it's the opposite. Each of those made the community more accessible than it was before. By embracing the breadsticks, Lockie made the release team feel more fun and inviting to many that were outside and on the fence about applying to be a shadow on the 116 release. People on that 116 release are to this day heavily involved in SIG release and in Kubernetes, and they feel strongly connected to the community. Cards Against Containers, besides being fantastic marketing, it takes that simple yet fun format of Cards Against that Cards Against Humanity has, and injects cloud native Flare into it. And it's another activity that, whenever in-person events finally resume, strangers can sit down and play immediately and feel connected to one another. You wouldn't think a hashtag on Twitter could really have a wild impact, but I know for a fact it did. The threads started small and wound up so big, multiple threads had to be spun off because we started hitting the limit of the number of people on a thread on Twitter had. Anyone could hop onto that thread, toss out a pun or a Star Trek Kate's joke or Kubernetes joke, and then you're in. And as for impact, I know several current contributors that really integrated into the community with this thread being a catalyst. How do bots have such a large impact? Well, automation in the Kubernetes community is almost a meme, and contributing to the project unfortunately doesn't have a very low bar to entry. Part of that has to do with many different slash commands we use within GitHub. A simple /woof or /pony yay is a gateway to people seeing and understanding that automation. Oh, and you want to write your own plugin for Prow? Well, let me show you this lovely and simple example regarding a goose picture and the ability to do /honk. All of this comes right back to Honk CTL, a goose-themed security CTF, or capture the flag, based around Kubernetes and fun, silly objectives. It evolved quickly in a short amount of time, going from one night of hacking with the Twitter API in Golang, to the next night, Alex Ellis installing inlets on my poor laptop and finding my IP address, which made me belly laugh, but only after I shut down the server and then rebooted my router, because that's a little scary, but it was fun. I pulled Bob into it, as I do with any of my wacky ideas. We iterated fast, and we had fun doing it. And we let anyone and everyone join in and try and break Kubernetes in the random instances we did. We also encouraged them to jailbreak out of our game and just enjoy themselves in a Kubernetes sandbox with no real rules. Some of the Honk CTL games were multiplayer, with everyone interacting with the same cluster and all of the chaos and mayhem that provides. The later ones were we removed a certain element of the chaos and provisioned mini clusters for each participant. That game grew. At the last challenge we ran, it was quite literally Untitled Goose Game, but in Kubernetes. Through various pivoting through RBAC and service accounts, players had to make their way through several levels, or namespaces, to eventually find a bell. Many played, but the dream team of Sig Honk, comprised of Ian, Brad Giesman, and Duffy Cooley, were the first to complete it, with several others finishing shortly after. For the record, Bob was the genius behind that last challenge, and you can all play it locally by installing Kind, or Kubernetes and Docker, and running the manifests in the Honk CTL repo. Because just like all the other examples from before, Honk CTL wasn't just silly fun or an inside joke. It was a way to make Kubernetes security more accessible and be used as both a sandbox and a teaching tool. When you can take a complex topic or a subject with a high bar for entry and make it extremely easy to explore or break things without any repercussions, people's curiosity will take over. I might date myself a little bit, but I remember when I was growing up, we had a computer, and my parents were always really worried about breaking the computer, like even clicking something wrong. And if they just had that kind of sense of, I can fix it, or I'm not really going to break it, I feel like technology would be more accessible to them. And if you can give, a sandbox a little bit of structure or a goal to strive towards, it helps drive people to learn more without realizing it. So what does one of these games look like? Well, I'm going to show you how to spin up the last challenge quick, and then we can take a look. One thing though, this assumes you do have Golang, Docker, and Git installed. I won't go over installing those, but I'll go from there because I kind of want to show again, that barrier for entry for this. All right, hopefully, can someone say that they see the terminal? Just because Alt-Tab, don't want to make sure. Yay, sweet, thank you. All right, so first, thank you. First, let's install Cube Ctl. I already have Cube Ctl installed, but I still want to go through these steps. If you Google install Cube Ctl, you will get a Kubernetes doc page that has many different ways to install it. I'm going to choose the one that just curls and downloads a binary. Seems the simplest. I'm then going to ensure that it's executable. And then I'm going to move it into my path. Sweet. So I have a client. It is 120. Fun times. Now we need to go get kind. Or arc. Yep. Again, I already had kind installed, but I do want to go through all of the steps here. So kind is installed. Cube Ctl is installed. We're good. Gianluca mentioned the KNS plugin, and there's also a KCTX plugin. It's Cube Namespace and Cube Context. I'd highly recommend anyone and everyone interacting with Kubernetes clusters with the command line getting those because they allow listing and switching namespaces and kube config contexts with ease. Oh, nice. There is a bug about stable.txt pointing to, well, we'll see if that actually breaks this or not. I would be amused if it did. It would also be my kind of presentation. Okay, so now we need to go and grab the public honk.ctl repo. Anyone can grab this, it is public. And if we go into honk.ctl and then go into challenges and then 2020 March, that's where we need to be. So the first thing we need to do is create a local Kubernetes cluster, but we need to specify a specific kind config because one of the things this challenge did was enabled alpha features in the API server. I may or may not have already done this. Kind, delete, cluster, there we go. Oh yeah. I'm doing this just to make people angry. Now, let's create a Kubernetes cluster using kind. This may take a little bit of time depending on if you already have the node image downloaded or not. In this case, I do. But I also want to go over while this spins up what we're going to do next. There are kind of stages in which we need to apply the manifest. So we're going to apply manifest 1, manifest 2, manifest 3, and then there is a helper script called goose.sh, and what that will do is it will configure your local kube config into the right context to start the game. So what we're going to do first is apply manifest 1. We're going to apply manifest 2. And last but not least, we are going to apply manifest 3. Lastly, we will do goose.sh. And then if all is well and you do Cube Ctl get nodes, you should get something that says it's forbidden. If you This is actually funny. The last time I did a presentation with this headset shuts off after like 20 minutes of no audio, which it just did. So if you do Cube Ctl get pods, no resources found in the garden namespace. Now what happens if we do, I'm only going to show you how to start this. It's going to be kind of a hint. What happens if you get Cube Ctl get CRDs? They're to-dos, much like the Untitled Goose game itself. Oh ho! So now we have our to-do list to then proceed. And if you happen to you might get things like a hint, you might get a to-do. So this is kind of the beginning of what do I do to try and steal the groundskeeper's keys. Sometimes one must become that they honk to reach one's goals. Well, maybe that means you need to try and pivot around permissions. Maybe you need to do like a Cube Ctl as a different service account. So that was the last challenge in a nutshell, and you can follow all of the to-dos, and eventually you can find your very own bell. 2020 has been a wild ride for many, myself included. Therefore, the next and rather interactive attack defend challenge involving SIG honk hasn't been scheduled yet. We've talked about it since the summer, but trying to get everyone's calendars to align, and also with people moving around, it's pretty difficult. What I can say is we do want to try and make it happen this year, and I promise it won't disappoint. That said, let's brainstorm another game. Let's think about a game that's been skyrocketing in popularity for the last couple months. It has a low bar for entry. The rules are simple. It has unlimited potential and fun. Something we could build our next challenge slash teaching slash. I'm going to talk about Among Us. I'm going to be making a game based on Among Us next. Among Us, for those of you that don't know, is a game much like the tabletop Mafia or Werewolf games. In this game, you and a team of others must run around and try to complete tasks on a map. Everyone is given a different task list, some of which overlap, and while people are doing tasks, no one is allowed to talk. However, among you may be one or two evil imposters whose sole mission it is to sow mayhem and eliminate all the other crew members. In the game, the imposters win if the number of alive imposters becomes equal to the number of alive crew members. So if there are 2 imposters and 3 live crew members and one of the imposters kills a crew member, they win. The crewmates win if they can complete all of their tasks or if they can eliminate all of the imposters. How do they eliminate the imposters? Well, the crew can send people out of the airlock by voting them off the island, so to speak. During these crew meetings, people can talk, argue, debate, or stay silent. It's all about tactics and sussing out who's not doing tasks. It is a hilariously fun game, and I would be happy to play with anyone who thinks, yep, I can betray my friends and lie to their face. So, how can we turn Among Us into a cloud-native fueled game? Well, let's think about what if you had to keep a workload alive by identifying malicious or misconfigured components running inside your cluster? The idea would involve things like adding disruption budgets or identifying workloads that could a node. This isn't multiplayer, but it becomes a fantastic tool for people new to Kubernetes applications and fault tolerance to learn common patterns and best practices while having some fun. Instead of Among Us, it's Disrupt Us, a wacky game of intrigue and workload management. Yep. You see all these copy pastas on Twitter about fill in the blank phrase, and I look at this one. I can't even imagine what many people would finish this with. Complex or unachievable, boring. I want to change that. Cloud native computing is fun. Yes, it can be complex, but we can make it fun. Instead of a steep learning curve, we can kind of build a ramp together and bring everyone with us. And I have to be a little bit meta. Jerome's talk was a perfect talk to follow up, considering one of his first slides was, let's play a game. I'm sorry about the screenshot, though. I probably could have picked a better one, but I was rushing. All I want to do is have fun with all of my friends and all of you. The more fun we have together, the closer we become and the further we can go. So what can we build together? What silly, crazy, or fun ideas do you have? I can't be the only one. Let's try and have some fun together. Thank you.
All right. Thank you, Jeffrey. So we still have some time for questions. I'm not sure if people have any questions here. We have 1 minute for questions. So please drop them in the chat here. All right. It was a truly fantastic talk. Thank you a lot.
Yeah, thank you.
All right, so let's invite our next speaker now. Our next speaker is Lee Code, who will share his experience with Meshery, the service mesh management plane. So You should be a presenter now.
Hello. Hello.
Hi, Lee.
Hello.
How you doing today?
Boy, this thing gets zoomed up in your. I should have brushed my teeth. Good. I know everyone knew that was a joke. That's good. Okay. All right. Very good. Thanks for having me, Amy. Thanks for having me, Chris. It's nice. Looking at the folks that are online right now and see quite a few familiar faces. Some of you might recognize that my eyes are slightly red. Very little sleep these days. Lots going on in service mesh land. It's meshy out there, I guess is the way of putting it. There's a project that I wanted to talk about. It's called Meshery. And just about as soon as I navigate my way around where the present button is.
You should be able to see the share screen button in the bottom of your screen.
There, that's beautiful. All right. So hey, here's a nice thing. Well, one, I thought, Jeffrey, I'll follow up with you later, but I'd love to get the make and model of your headsets. It seems like a nice way to stop a monologuer. There's at least one narcissist that I know that I need to give that to. For my part, since I'm gifted with the ability to just listen to myself for an hour. That won't happen today because in half an hour, I'm going to go talk more about, Istio, another mesh. So I just caught the tail end of Jeffrey's talk and noticed there was demonstration and things. And so I have slides, but if we go through these quickly, we'll do some demo items. We're focused on service meshes because, it's lines up beautifully with a lot of my experience and my historical focus on management software, on networking, on observability. And so service meshes hit a sweet spot for me. I'm off spending a lot of time building a community of, a little over right around 1,200 learners, operators, open sourcers, really kind of the largest collection of service mesh centric folks. I think it's truthful to say that that's in the world, considering that each and every service mesh that I'm aware of which there are a little over 20, depending upon how you count, are represented in that community. And so we're just really focused on what we consider to be this upcoming, sort of slowly upcoming, if you will, layer of infrastructure. Part of the role that I get I'm fortunate enough to participate in the CNCF is as a co-chair of SIG Network. And we've seen some new entrants into the CNCF recently. Hopefully you all have noticed Open Service Mesh come into the CNCF, brought to us by kind of some similar folks that were involved with Service Mesh Interface, or SMI. And so it just keeps getting, I'm going to stop trying to use what's probably not a funny pun, but we've yet to see the last new service mesh announcement, I think. If you're paying attention, it sort of trickled out over the last 3 weeks now.
So we don't see your slides right now for some reason, and we can see them in here. Yes.
In here.
Yep. It's good now. Thank you.
You guys missed all the wonderful animations and the yeah. Okay.
Yeah. you can show them again. Yeah.
I was just thinking about having to listen to myself talk more. That's horrible. I don't know that we missed much other than here's just a quick perspective that grabs a couple of the service meshes that are out there and highlights some of their strengths. These are simplified characterizations that hopefully acknowledge why it is that, at least for my part, I consider that choice here is good. And so, as I was saying before, one of the latest service meshes to be announced over the last couple of weeks is the Nginx service mesh. And so, kudos to that team for well, a couple of things, but one of them is aligning very well with Service Mesh interface. So one of our collective projects. The REST API for Nginx Service Mesh is SMI, and essentially only SMI. So that's pretty neat. So kudos to, and that was sort of a similar story for Open Service Mesh as well. So that's pretty neat. There's a number of reasons why we have different tools. It probably doesn't necessarily need that much explaining, other than to say, today it is the case that enterprise or infrastructure diversity is a reality within enterprises. And certainly I would think that we would expect to see a lesser number of service meshes out there, or at least we would certainly continue to expect that 2 or 3 of them really enjoy much of the market share, if you will, if you measure that by adoption. And so because of that, and because there are a number of them out there, some specifications, some standard abstractions have emerged. So we mentioned Service Mesh interface here a moment ago. The open source project that I want to talk about today, Meshery, we'll talk about how it marries up with SMI. There's another emergent specification stewarded by VMware. It's called Hamlet. It is complementary to SMI in so much as Hamlet is much more oriented for describing a service mesh's catalog and letting 2 different service meshes, whether they're of the same type or not, have a common set of APIs for exchanging their services, exchanging their catalogs. And then SMP is Service Mesh Performance. And it's a standard way of describing and capturing, kind of articulating service mesh performance. And that's one that I've spent a fair bit of time on myself. We've been fortunate enough to collaborate with a couple of universities. There's a lot of research to be done around what happens to systems performance when you're using microservices, when you're running distributed systems. And having a service mesh present really helps facilitate controlling those types of environments a lot better. And so there's a couple of reasons why SMP as a specification has come about. It's come about initially in collaboration with Google. We don't see their logo represented here, and that's for legal reasons, but a lot of work had been done with both Google and IBM, whose logo we also don't see here for similar reasons, but was to acknowledge that performance is a real, and overhead is a real concern for those that are adopting this type of infrastructure. And that the more that people use or ask a service mesh to do, the more that you would expect that the more overhead that you would expect that it incurs. That's not always true. There is a lot of considerations and variables to understanding the performance of a mesh, its impact, what functions you're asking it to do based on your workload and what service mesh you're running, what architecture it has. And so we presented this last Kubecon EU with a PhD student at the University of Austin, Texas, and have much more research to do. We've been engaging with the Envoy team and the Nighthawk crew. Nighthawk is a load generator of the Envoy project and is actually increasing in popularity. Now, Nighthawk is, as versus some other available load generators like Fortio from the Istio project. There's so much to pack into this time here. I kind of rambling across some topics, I think, but anyway, suffice to say, this service mesh performance is a deep area and riddled with interest from both vendors wanting to be well represented and users as well, wanting to understand what's going on with their infrastructure. The nice thing is that service mesh really does help people look at, answer those questions with one tool. So service mesh management is, can be thought of in my mind, in terms of sort of the three planes of a service mesh. So, probably I expect most of us on this call are familiar with a data plane and the fact that it's composed of proxies, intelligent proxies that are highly capable, and oftentimes fairly modern proxies that are designed for microservices environments, those that are designed for developers. And when you get a bunch of those proxies, you end up wanting to do configuration management over them and manage their health and deploy them, and a number of use cases inside the control plane, collect telemetry, enforce some authentication and authorization, a lot of security, a lot of use cases. And in part, it's not just because there are multiple service meshes, but that you need a management plane, but also because for any given service mesh, the control plane is only going to take some of what you need so far. Probably a really simple example to grasp might be something like doing canary deployments or blue-green deployments, or different continuous delivery techniques. The control planes themselves that isn't necessarily part and parcel to their area of responsibility per se, but a management plane layered on top can really help with a number of different use cases. Some of which is bringing together disparate service meshes. One of the things that's characterized here is the fact that if you're familiar with, or beginning to get familiar with WebAssembly and how support for the WebAssembly, the WASM, virtual stack as a VM is beginning to garner support inside of Envoy proxy. It's on the roadmap for Linkerd proxy, and hopefully with the help of Community Bridge and some interns, it might be into OSM as well, Open Service Mesh support for WebAssembly. So Meshry is an open source project that we'd like to propose for Sandbox in the CNCF. It was launched as a supporter of SMI when SMI was launched. It's the canonical implementation of SMP. It's on the CNCF landscape. It's CII, I forget, it's the first rung of compatible. I forget that name, best practices. The value that it provides in this particular management plane provides is one of those is around best practices. It's service meshes are quite powerful. You can configure them to do a lot of different things. You can also shoot yourself in the foot and misconfigure them to not do what you expected to do. And so this tool builds in some best practices and helps you, analyzes your service mesh config and tells you you're doing it right, or if you see a bunch of red boxes, you're doing it wrong. One of the areas of focus for just me personally, I'm authoring a couple of books with O'Reilly at the moment. Soon, hopefully just one, and that one is called Service Mesh Patterns. There'll be 30 service mesh patterns inside that first book, probably a subsequent book for another 30. It worked out to 60 pretty evenly. Point to bringing these up is to say that part of that focus is beginning to build in some of these patterns into Meshry as a management plane so that people can operate their mesh with confidence. Speaking of operating with confidence, if you think about what Sonobuoy is to Kubernetes in terms of validating a given Kubernetes distribution of software as actually being Kubernetes and passing some tests. We've been, as an SMI maintainer myself, we've been working with the rest of the SMI crew to define tests that or assertions that would verify whether or not a given service mesh and a particular version of that service mesh is compatible with one or all four of SMI's specifications and particular versions of those specifications, and then guaranteeing provenance of the tests that have been run or the results that are sent in from the different participating service mesh groups. And so there's a lot to orchestrate maybe for running those types of tests. You got to deploy it service mesh, any one of them that are participating in SMI, deploy a sample workload, generate some load against that workload, run these tests and verify whether or not the test passed or failed. And so Meshry was made for a great tool to do that, since it already did 3/4 of what we needed for it to do. Boy, the spacebar button doesn't